The second part that I want to talk about is the advanced analytics piece. So machine learning and Azure ML. Back to I want to revisit the analytical continuum, and to refresh you that, I was just talking a lot about diagnostic analytics, and now I want to bridge over into the predictive and prescriptive. And that brings us to our second chasm, because to use the same graphic but to put different things on each side of the chasm, we've descriptive and diagnostic, actually they're kind of easy because they're knowns. It's just taking stuff that we already have and making sure that people can get their answers from it. To go to predictive and to go to prescriptive, that's when it takes a little bit of pixie dust. You're dealing with probabilities, and you're starting to make decisions based on things that you don't know. It's all about things you don't know. And so that's a huge jump for us. And there's two different things that allow us to bridge that: tools and skills. And vendors like Microsoft are doing an excellent job, as well as stuff that Mark's going to show you from Pyramid Analytics that will, from a tools perspective, solve that with no uncertainty. The hard part sometimes is a skills piece. The ability to use those tools in a deliberate and intended way with the intended outcomes. So sometimes when we talk about machine learning and data mining and predictive analytics, we think of it as a swirling crystal ball and a lot of black magic. And I love this graphic because it kind of does both there. But it looks a lot like the Firefox. I just noticed that. Holy cow! I have to go look at which clip art I took that off of. That's funny. Sorry, Microsoft. But just to put us all on the same page, a really basic description of machine learning is this one that I pulled out of Introduction to Machine Learning. It's from MIT Press. And it says the goal of machine learning is to program computers to use sample data or past experience to solve a given problem. So where would I use it? These are a lot of use cases. You can read through each one of them. Some of them I've already given you some examples. You're here because you probably have some gaps in your environment and say, hey, I've got people asking me about what might happen surrounding a certain thing, a certain scenario. But every industry vertical has a need for machine learning and can value and get more value from machine learning. There's two main things that I'd like to point you to is the whole concept of having to do more with less. We've got all this data, we're persisting it, we want to get value out of it, but the reality is that we've got to do more work with less resources today, and usually human resources. So to use, I was talking to a public sector crowd recently about machine learning. And there's a number of different police departments that are using machine learning to determine where crime might happen. And then therefore, with the number of officers that they have, proactively patrolling those areas to prevent crime. It's the exact same use case as preventative maintenance in a manufacturing environment. Is saying what is likely to break. Therefore, what should we proactively replace parts on? A lot of you actually have that in your cars now. I know that my dealership wants to replace a certain part in my car at a certain mileage. And I say, well, is it broken? No, it's not, but it's probably going to break before your next service time. All of that is a preventive maintenance. machine learning use case. Healthcare, looking at what they call train wrecks, where somebody goes off their meds or isn't regulating themselves with insulin if they're diabetic. And healthcare insurance providers want to prevent that as well, because if they can do preventative maintenance on us as humans, then we're less likely to run up a big healthcare bill or clog up hospital ERs. So all of those are use cases for machine learning. Mark's going to talk a lot more about that. I want to bring back the big data slide, not to walk through it again, but just to revisit the concept that we've got so much data that we don't know what to do with it. And actually, that's a prime use case for machine learning, is understanding patterns that we wouldn't normally see just by looking at data. When we go through and we build corporate BI, we go through and we say, well, what reports do we need? So therefore, we need to build this type of schema. How will people want to intuitively interact with the data? So we're building something because we know that there are certain questions to ask. But we have so much data available to us that we actually don't know what questions to ask. And certain algorithms and methods of machine learning are actually targeted at that, seeing where there's patterns in data and helping you understand what type of questions you want to ask of data. So just because of the data explosion, it demands machine learning because it's gone beyond what we humanly are capable of doing, and we've got to throw more compute power at it than what we've had to in the past. Don't know if we have any folks that have done machine learning and data mining in the past, but here's an old school graphic for you. There's the most popular methodology for data mining. Actually was started in 1996, this was conceived. And I love to put this up here because it demonstrates the process and the discipline around data mining and machine learning. And those of you that are newer to it or may not actually be doing it yourself, you're a business leader and need to understand kind of what the mechanics of it are. Love to walk through the CRISP model because it's all about, and it's very business centric. There's another model called SEMA, and it's really technically focused, where I like CRISP because it starts out with business understanding, saying, what is my business? What is pertinent in my business? Sometimes you know that, sometimes you don't. And then saying what data corresponds to what I know about my business. And then you prepare that data, you go through a process of modeling it, running algorithms on it, a process that you called training a data model, and then you look at how reliable that data model is by taking some of the data, keeping some of the data back that you have, and you know the outcome for, and then you run that through the model and see how well the model did because you actually know the outcome of some of your data. You pull some of that back, and that whole process is modeling and then evaluation of your models. And when you have something that you want to adopt, that you want to implement, then you deploy it. The only reason I bring all this up is not just a data mining primer for you, but to say that I'm not going to get into all the different algorithms, and this is when you use clustering, this is when you use decision trees, and this is not going to walk through that. Mark's going to probably touch on that a little bit, but I want to talk to you about Azure ML and why it's a real game changer for us, because there's been this chasm. I said there's a chasm between the getting from diagnostic to predictive, and the bridge there is the tools and the skills. Well, the tools have been a big impediment to this point because of all the things that you see on the left-hand side here. The tools have been very expensive. They've always been siloed and isolated and run by those skilled people, and then the deployment of it is very complex. What do you do with the outcome? we have data scientists, we've had data scientists for years that is the answer guy or answer woman that is bolted to the hip of the CMO in a company. And they go off and they run their algorithms and they come back and they never deploy. They actually just come back and say, you should do this, or this is the probability of that, or it ends up in a PowerPoint that came out of the Python code that they wrote and they crunched, and the SAS that they ran and implemented under their desk or isolated from the rest of the environment. But now we actually have this thing called the cloud, which is allows us to have basically infinite compute elasticity, infinite storage elasticity, and the ability to access it through APIs and plug it into, whether we want to put it back into corporate BI or we want to make our applications more intelligent. There's no boundaries to it now. And that's why Azure ML was built as a cloud machine learning engine. So looking at it, there we go. Why? Why would we use this other than so many, how does it differentiate? This is not me with a sales pitch. This is me saying that this is a decidedly different way to do machine learning than how it's ever been done before with the cloud-based engine. Being that it's built for cloud first and a mobile first world means that it can be completely housed in the cloud and it can be implemented in whatever format you need to do it. Fully managed, you can go, actually, this is really cool. Microsoft is using a freemium model for Azure ML. You don't have to pay a cent to use Azure ML until you get to a certain level. So you can go out right now to, I didn't grab the URL, but I think it's azureml.com or Azure, azure.com/ML, I believe. And sign up, and you can be using it in 5 minutes, less than 5 minutes. You can be logged in and start playing with it. There's sample data up there, there's click-throughs, there's the maturity of the readiness and training around Azure ML is phenomenal. So you can go and do a tutorial. Even if you're a business executive, you can go and click through. I was part of the, I don't actually do machine learning on a day-to-day, as a day-to-day task these days, but I went through I was part of the early adopter program and did all of the samples. I would encourage you to do that. So it's fully managed. No software to install, no hardware to set up. You just go out and start using it. Integrated, you have a full IDE integrated developer environment, so that's browser-based. It's very, very slick. Allows you to go and set all that stuff up. But then what's under the covers will make any data scientist smile, because it's got all these algorithms that are built in, it's got extensibility, and you can even use R scripts in it. And then once you deploy a model, it sets up APIs for it so that then you can integrate it back into anything that you want to, and take your data, stream of data, and do prediction joins into the cloud and get your results back. Inside of a line of business application that you want to add intelligence to, add it to your extraction, transformation, and loading process in your corporate data warehouse. Even make calls in a visualization environment where you want to take what data you're looking at in a given report and bring it in. There's already a project out on CodePlex to allow you to pull it into Excel, and I'm sure that we'll see that in the next version of Excel built in. So I don't mean to simplify all that. I just need to make sure that you know that there's a different way to go about it, that we can get across that chasm where it seemed insurmountable before. I come from a cooking background. Actually, I'm on my second career. And back in, I guess it was the 80s, a brilliant engineer came up with microwave cooking. And all of a sudden, now we all have, we can all buy a microwave for less than $100. And it's an amazing thing. You know, you can boil water in no time, and the technology is fascinating. But I just want to point out that it's not the best thing for everything. You know, you don't want to microwave everything. Just because it can be done doesn't mean that it's right. And so that's where I'm really emphatic about the fact that bridging that chasm is tools and skills. You still need to know what to do, how to use the technology, where to use it, so that you get the outcomes that you can rely on, that you can run your business on. So back to the whole CRISP model. You know, this is a good methodology to use. Azure ML actually is built so that it works perfectly with the CRISP model, but the fact that you can deploy in minutes means that you can screw things up really quickly and make really bad decisions without the right skills. So I want to talk about the gap. Slides are slow advancing, and maybe the link connection. So Azure ML enables predictive and prescriptive analytics. You know, that's, of course, without predictive, we can't get to prescriptive. And understand that this is a huge pursuit for most C-level executives today. Fastest growing space within analytics, you know, 17.9 or 0.8% yearly growth. It's going to be a huge 6.5 billion by 2020 or 2019. But understand that it's decidedly different technology purchase and investment that's happening now, because it's almost always owned and initiated by the business. Rarely is it initiated by IT, and often the budget for it comes out of the business. And it's really important for IT to be aligned with the business so that there's not this fractured adoption of technologies within your environment. So I know that I'm talking to folks in the room that live on the IT side as well as folks that live on the business side. And as frustrating as you are to one another, it's really important that you guys are in sync with this so that you can, to go back to the first part of my discussion around the model promotion piece and using a collaborative platform for promoting model promotions, all the way through bridging the gap to predictive analytics. So we're going to see a lot of custom and packaged apps. We'll continue to need predictive analytics. But then where you bridge it back into IT is making sure that those things those insights find their way back into your enterprise data warehouse and your corporate BI initiatives. If you don't do that, you haven't closed the loop. You're going to turn your corporate BI, which is table stakes, and it's not going away, but it's going to turn into more and more of a dinosaur in your environment. And it shouldn't be that way. It should be a living, breathing backbone to your business. And by integrating corporate or predictive analytics back into it, you're able to do that. I couldn't edit this slide. This is the data on it. So the typo there where it says "don't know" with 2 N's. I don't take credit for that, but the data on there is still very interesting. You can see that the light color bar graph there is what people are spending were planning to spend in 2012 versus the darker ones was 2009. So just a 3-year gap. This is from an Accenture poll. See where predictive has jumped up so much, as well as you know, equally both has dropped back. So people are definitely putting a lot more of their shoulder behind and spending behind predictive analytics versus the retrospective analytics, which is another way to say diagnostic and descriptive analytics. Lower right is a really interesting thing. A McKinsey study said that there is a data science gap of 300,000 data scientists. And that's why sometimes, if you've read any articles, you know, data scientists are sometimes called unicorns, or, you know, really hard to, and people are all trying to hire them, and everybody wants a data scientist. But The next metaphor that I wanted to use is the financial advisor. Is that I don't know if you've gone to a financial advisor in recent years, but usually the first thing they do is they say, well, put it all into Fidelity or put it all into Schwab, and then give me an analyst access to it so I can manage it for you up there. And so they're all using the cloud. Well, I just was telling you about this new machine learning platform that's cloud-based and will allow somebody to basically do that for you in your environment. They can be a data scientist that you don't actually have in-house. And so I've actually coined this phrase called the fractional data scientist. You know, last year my business was at a certain size, and I wanted a CFO during budgeting period, so I actually hired a fractional CFO, and I had his time for about 1 day per week, and that was great because that's kind of the extra help that I needed. But I didn't have to go and hire somebody and figure out whether I need a CFO all year round or not. And I think that the McKinsey study is true if people were going to go hire data scientists. But the reality is that a data scientist probably will spend a majority of their time doing things if they're in a full-time employment position, doing things that they're not most passionate about or using all of their data science skills. They're going to do a bunch of other technology filler stuff, data preparation, trying to get the value back out of the model by writing reports on top of it, and maybe that's not what they're best at. They're best at figuring out which algorithm is right and whether the model is the most reliable model and those type of things where it's a sliver, a surgical use of their time. And if you're able as a company, as an IT department, as a business user that needs the expertise of a data scientist, it's quite liberating to be able to say, hey, there's a platform that I can go get a data scientist to help me, and they don't actually even have to come on site. So I think that I don't want anybody to be discouraged by that McKinsey study where we need 300,000 data scientists. I just think we need to make better use of our data scientists that are out there. Yes, we need more, but I don't think the gap is as big as it is made out to be if we make more efficient use of them. So wrapping up, wine's great. You know, if we look at machine learning and kind of compare it to wine, well, the tools are good winemaking material, and if you've made really good wine, you need to enjoy it in a nice glass. But want to warn you that your experience for it may be degraded if you're drinking it out of the wrong thing. If you've got a red Solo cup and you're enjoying a $100 bottle of wine, there might be some misalignment there. So the opportunity, back to what I was calling the gap, or the opportunity for us to apply machine learning, is to understand that Azure Machine Learning is only an engine, and it really needs to be integrated. And that's a good and a bad thing, because it means that it can be integrated in any of the scenarios that I suggested before, making your applications more intelligent, making your corporate BI more intelligent, but also understand that even though you can click through and use it in 5 minutes, that the time to value really depends on you integrating it back into your environment so that all of your prospective users start to get value from it. And with that in mind, and back to what my comments about the fractional data scientist and making good use of, making efficient use of data science skills, is that understand that a lot of the heavy lifting around machine learning and data science is not just data scientist work. there's a whole bunch of application development and integration work and traditional BI work, because that's really the last mile with integrating it and getting value out of it. So keep that in mind and prepare for that so that you can get the full value from your machine learning. So with that, we talked about two different chasms, the difference between individual BI and corporate BI and bridging that. And then we talked about the chasm between diagnostic and descriptive and diagnostic analytics, bridging that to get to predictive and prescriptive analytics. Hopefully this was helpful for you. Hopefully you're encouraged and will invest and save some brain space for everything today so that you're ready to make that leap. Thanks for your attention.